This is a recording for Thursday, uh, November 15th, 7th hour math analysis, and continuing on with notes for 1-7. So in class, we just attempted this problem. If you would like to try it yourself and then check your answer, we just finished trying it, and then our little half sheets of paper should be in our folder now, and then we'll go over it as a group. And maybe you know why I said that. To those of you who are in class, why I said that even if you maybe know what the answer is, you want to be showing me algebraically. So this is f of x equals x plus 2 over x minus 1. So we rewrite that as y equals x plus 2 over x minus 1. Just a note to self, I forgot to say that I also told the people in here that it does have an inverse, so they didn't have to take time to graph it. And then to find the inverse, we interchange x and y. So x equals y plus 2 over y minus 1. I'm asking that you don't write on the half sheet of paper because really I don't want to see exactly what I wrote. I want to see what you did, and that's all I'm doing. Just like yesterday's half sheet of paper, I'm just taking it, looking at it, and throwing it away. You know, there's no score, there's no anything. I do ask that you put your name on it. And so now I just want to go over it so that you can kind of see what you should do. So our goal is to get the y's alone because there are y's in fractions. We're going to multiply by y minus 1 on both sides, and I would put everything in parentheses. Just a note to self, remember that those cancel off. I'm going to distribute over here and get xy minus x equals y plus 2. Personally, I'm going to get the y's on the left just because this one is positive and I don't know, it just makes sense in my head. And I'm going to add x to both sides and subtract y. So I'll do those in single steps. So I have xy minus y, and then actually I said single steps, but I think I'm just going to add x at the same time here. And so the x's cancel on the left, and then on the right hand side we have the x plus 2. The y factors out as a common factor, and we have x minus 1 and x plus 2. And then we divide each side by x minus 1. Oops. And we get that y equals x plus 2 over x minus 1. Anybody remember why I said you had to show this algebraically, even if you knew the answer, right? Because we found yesterday that, you know, it was the same thing. So f inverse of x is equal to x plus 2 over x minus 1 as we look at that one. For this one, the original domain and range were the same. The thing we had to be careful of, and since they're the same function, we know that there's no additional restrictions anyway, but either the inverse function or the original function it's undefined at x equals positive 1 because that would make that denominator equal to 0. And we talked about yesterday, you know, if these are the same power, which they happen to be here, then 1 over 1 would be that horizontal asymptote, and so it's undefined there as well. So the domain and the range of both is from negative infinity to 1, union with 1 to infinity, and that's the same as the range for the original and the inverse because they are the same function as we go. Then that's how to find algebraically an inverse. Sometimes, though, we can't do it algebraically. And so sometimes we don't even have an algebraic rule, and so we have to have other ways. So we'll do that graphically, and we'll do that in a minute. But then the other thing we'll have to do is maybe we'll be given a function and we'll be asked one of two questions. Are these inverses of each other? Or the other question might be, these are inverses, show that these are inverses of each other. And so just a note to self, if you're not a person who likes to show work, if it says show these are inverses, I have to see your work, and you can't make too huge of jumps, to say, oh yeah, this here it is, and it equals x. So if two functions are inverses of each other, then when we compose them, because remember they're reflected over that line y equals x, so two functions f and g are inverse functions if and only if f of g of x equals x for every x in the domain of g of x, and g of f of x equals x for every x in the domain of f of x. So that's what that means is if we have two functions, we're going to take f of g of x and see what that is, or f composed with g, and we're going to take g composed with f, and if both of them give us an answer of x, then we'll know it's an inverse. And so inverse functions, it's like you're doing something and then you're undoing it, and those are inverses then, if that's what the situation is. And I don't care what the directions are, if they are validate or are these inverses. In this one, we just have to show that algebraically. And it's not enough to show that one is the composition, or one direction of the composition equals x. We have to show that for both of those. So I just have one problem to show you of this situation, and we're going to be given f and g, and in this one, it's just show that these are inverses. So we know going into this that they are going to be inverses, but our job is to show that if we take f composed with g of x, we get x, and if we take g composed with f of x, we get x as well. And so if you write what is written on this slide, as your answer, that's not going to be good enough for us as we go. And so I'll write it so I kind of can time myself. So this is f of x equals 2/3 x plus 2, and g of x equals 3/2 parentheses x minus 2. And you might be thinking there's a lot of inverse things going on there. We're already aware that this is an inverse. So, you can see you have the 2/3, you have the 3/2, you have an adding 2, you have a subtracting 2, and kind of the order is what we're looking at there as we're looking at that one. And keep in mind, if you want to use your graphing calculator to show that these are reflecting, in your mind, to see if that's going to be an inverse. In this case, we know it's going to be an inverse. But if you're using your graphing calculator, keep in mind, we talked about the fact that that window is not square, and so it's not going to look like an exact, the y equals x is not going to look like it's making kind of a 45-degree angle with the x and y axis. And you can make that correction. So here's what all this is we know they're inverses, so we have to show. So we have to find f of g of x. And the way that I do that is I go down here and then I'm going to just put g of x in here and I'll color code it a little bit. So g of x is 3 halves parentheses x minus 2. And I don't have to manipulate that at all. I can just leave it like that. And then to find f of that, f means we're going to take 2/3 times x plus 2. And I didn't leave myself a super great amount of room. So I'm going to slide that over and rewrite this part. So this plus 2. And so in place of this x right here, I'm going to put my 3 halves parentheses x minus 2. And so it should be, something that's going to work out pretty well for us. And all I ask is that you show me enough work so that, I can see what's happening. If I do this problem, the first thing I would do is maybe multiply 2/3 and 3 halves, right? Because that's going to be 1/1. And so that's not too much of a jump. Please don't just write, oh, it's x, because yes, it is, but I need to see that. So I think I'm going to multiply that. 6/6 is 1. So then I am left with the x minus 2. It's in parentheses right now, plus 2, and then that's x minus 2 plus 2. You wouldn't have to write both of those, but maybe write one of them for sure. So f composed with g of x is x. Do be careful because we know compositions are not always the same. And if you're trying to determine if these are inverses, one of them could be x and one of them could not be. And so our other one is g of f of x, and we know it's an inverse, so we're just going to kind of put it in there. So g of this f of x function, 2/3 x plus 2. And now we're finding g of that, which is 3 halves, parentheses. My x is going to go there, minus 2. And my x is going to be this 2/3 x plus 2. And, for this one, I could either distribute that through. I probably would not do that because I would say, oh, look, 2 minus 2 is 0. So it's 3 halves times 2/3 x. Those added to be 0, and then it's x. So that one was pretty straightforward as we looked at that anyway. Here's my graph, and I feel like I changed this slide the way that it's on here. So it might even be a little more skewed differently because mine looks a little more square or something, a little funny window. Oh yeah, so my window goes from -15 to 15 and from -10 to 10. That should make this look at a more of a 45-degree angle, the line y equals x. And if you put the line y equals x in there, it should easily reflect over that. Now, the next thing I want you to do, I want to go on a piece of graph paper, and you're not going to get a rule, and I want you to just draw your axis with a straight edge, and we'll probably draw that y equals x line. So I'll give you enough graph paper for anybody who's maybe not here, and then that can just go in your folder, and you can have a straight edge for this. So I think put one in the folder there. Back. That's all right. Okay, so for this one, and partly we're testing our graphing skills, and I've already told you that this is a weakness of mine. So of course if it's a weakness of mine, what do you think I did? I practiced, right? So I shouldn't even tell you that I practiced, because then if I have trouble, it'll even be worse, you know. Oh my gosh, she practiced this and that's what she's doing, but whatever. So inverse functions of most one-to-one functions are often difficult to find algebraically. Okay, so make sure you've read that, because we just, yesterday and at the beginning of the hour now, we found that algebraic inverse, but sometimes that's just not something that is going to happen very easily. Think, for instance, if it's like, remember those compositions of functions, the inner function and the outer function, and that if we had like x squared plus 5x plus 6, we have to complete the square to get it to be an inner function and an outer function because of the x squared and the x. So a lot of functions, it's super hard to try to put that y in for x and try to get that alone. So sometimes it is possible to have a graph of a function and then to draw the line y equals x and then reflect it over there. And I'm just going to tell you, Janet Jones writes in pencil when she's doing this in real world, and on the board I can't do this because I do the dark shading and rubbing. I make a rubbing of the graph. So when I draw that line y equals x and I have my original graph, I just trace over it in pencil, right? Fold it in half, make it, give that little image, and then I can graph it. And so that's a helpful hint for me. But we have to graph this, and I evidently forgot to make this white. And so, I still did not do that correctly. There we go. So I'm going to grab a piece of graph paper, hopefully, here, and then I'm going to graph this. This is what you would get, but I'm going to graph it with you so that we kind of all have the same thing. And so this is our function. We don't have a rule for this function. So the first thing we have to do is draw a decent picture of it. So to draw a decent picture of it, I've got to find some points here. And, this just goes from -5 to 5 and -5 to 5. I used to have a littler graph, but I guess I don't anymore. So that's all right. And so I'm just going to graph it in that area. I'm going to notice some exact points that I think I can plot. And we're going to plot those points. And we're going to write them in a table of values. So this is x and f of x. I believe some of our points are -2, 0, -1, 2. Oh, -1, 2, sorry. 0, 0. 1, -2, and 2, 0. So I want you to plot those points, and I wouldn't go past -5 and +5 when I'm graphing that. There, and I'm going to put like a little extra mark right there, kind of just so I can see kind of about where that's going to be. And then you want this to be a kind of decent graph, because that's going to help you as you go. And we're just kind of graphing it in that area. So, we want to do a decent graph on that. Oh, I used the wrong color. The only reason I say I use the wrong color is because my automatic dashed line is green, but that's okay. The next thing I'm going to do is I'm going to graph the line y equals x. And I know my graph is a 10 by 10, and so I can use my straight line drawer, and you want to use your straight edge. And I'm using that green. I'm going to change it to blue just so I have it here. And maybe I'm going to use those dashes and this line. And, because mine goes from -10 to 10, if I'm careful, I should be able to just go from one corner to the other and it be in the right spot. But evidently that's not happening super great either for me. Huh. Boy, my board is, or my graph paper is a little off there. Well, that's going to be as close as I have. I don't super love that line, but that's okay. So that's my line y equals x. Note to self, remember if I compose f of x and f inverse of x, I get x, right? So anytime this graph crosses the line y equals x, it means that the x value and the y value are the same. So not only does f of x cross right there, and I'll write in yellow so people who are maybe looking at this, since this crosses right there, the inverse will have a point right there. Obviously 0, 0, is going to be the same, and the inverse is going to have a point there as well. So that's always going to be kind of an extra point you're going to get, and I'm going to get rid of all that because I don't really want that on here right now. Now, I did try to find some points because I can plot the inverse points. What do I do to do the inverse? I interchange x and y, right? So that's exactly what I'm going to do on my table of values. So my new table of values is going to be x and f inverse of x, and all I'm doing is, and I'm going to write in yellow a minute, I'm going to take these x's and y's and I'm going to interchange them. And so let me get rid of the yellow now because I want to write in red. And so my negative 2, 0 is going to be 0, negative 2. My negative 1, 2 is going to be 2, negative 1. My 0, 0 stays 0, 0. See, that should make sense as well from what we said before. My 1, negative 2 is going to become negative 2, 1. And my 2, 0 is going to become 0, 2. So my next job is to plot those points because that's going to help me kind of be able to graph that as I go. So I'm going to plot those 2 points, or not 2 points, that series of points. So I've got 0, negative 2, which is down here, and 2, negative 1. And then 0, 0, it's going to cross there. And then negative 2, 1, it's going to hit there. And then 0, positive 2. And then if you're graphing still, look at the smartboard a minute because I'm going to add 2 points. I don't care really what they are, but where the green line crosses the dashed line, I know there's going to be an inverse point there as well. So I'm going to just put a dot at that one and where that one crosses as well. So really, when in doubt, fold your paper in half. Of course, at the smartboard, I am not able to do that, so that makes me sad a little bit. But hopefully I can do this. So here's what it's going to look like. Are you ready? It's going to be, as it comes, it goes like that now. It's going to go like that. Got it? And so now you draw it in. And I feel like it's going to come, and then I'm going to go 1, 2, 3, 4, 5. Just try to, there we go. Ah, Janet Jones crushed it. So it worked for me. Yay. And, I did practice it. Actually, I made myself practice another one too. So, so there it is. So graphically, and if you can always take your graph paper, and darken that and reflect it, because in my head, even when I'm plotting those points, did you feel like when you were plotting the points, it's like, where am I going? Because they're not like sequentially like these points are. The original points, they're not sequentially. We're kind of jumping around a little bit as we graph them. So that is the graphing problem that we wanted to be able to put on there. So please make sure you're labeling those and someplace near. So this one is going out there. I'm going to label that as f of x. I'm going to label my blue line, dashed line as y equals x. And I'm going to label my red graph, because mine is color-coded, as y, or f inverse of x. I'll just write it that way. F inverse of x. So that we know we have three different things happening on there. And so we should be able to do three things. Find the algebraic rule for the inverse if it exists. Validate or decide if two algebraic rules are inverses of each other, and then not having any rule to go by, but only a graph to be able to graph the inverse. And I feel like in my mind, yes, I believe that's why I gave you these three problems, or I told you to take those. If you did not take the handout for 38 to 42 the even, and you're not here, it's in my room. If you're in here, does anybody need this? I told you if you wanted to pick it up after the quiz, you could, or you didn't have to necessarily then. So I'm just going to give it to people who feel like they need it right now. And anybody else not grab that one? And just in my mind, I'm guessing that's what these problems are. I don't know 100% that that's really what they are, but I'm guessing that's why I gave you that handout and everything, because I'm not looking at the book right now. Okay, now we want to move on, and we want to think, why might we want to have that inverse function as a rule so that, we don't have to continually kind of find values by putting in the y and trying to figure out what the x is. So do you agree with that? If we have a rule y equals and whatever it is, if you're told if x is 4, you just put x in there and it's easy. Do you agree that sometimes in your life, if you've been told what y is, finding the x that matches it is a little more hard, right, or more difficult as we go. So if we can find an inverse or write something as an inverse, then that'll just make it a little easier for us. And this is a linear equation. Do you agree that almost every linear equation is going to be a function and have an inverse function? And do you know why I say almost everyone? Because I just said linear equation. And so if we have y equals 3, right, that's a horizontal line. Is that a function? Y equals 3? Yes. Is it 1 to 1? Does it have an inverse function? No, because it doesn't pass the horizontal line test. When we get to 3, every value is the same. And same with the other way. If x equals 2, is that a function to begin with? No, it's a vertical line, is not a function, but then its inverse would be a function. So anything else that has a slope that's not 0 or undefined will be a linear function, and it'll have a it'll have an inverse function. So this is a manufacturing problem, and it's number 5. The fixed cost for manufacturing one type of stereo system is $96,000. And the variable cost is $80 per unit. The total cost f of x of making x stereos is given by f of x equals 96,000 plus 80x. Explain why the inverse function f inverse of x exists, and then find it. So this is number 5, letter A. We have f of x equals 96,000 plus 80x. Just a little note to self, what does X stand for? Number of stereos, right? And what does Y stand for? What does Y stand for? So, right, the total manufacturing cost. Manufacturing cost. So just to kind of have that in our mind, because I just know they're going to ask you some things about that relationship. So does this pass the horizontal line test? 96,000 plus 80x. Yes. And so, you could graph it. I think you know that. And so does the inverse exist? Yes, it has an inverse. And it says explain why. Because it's linear with a slope of 80. And so it passes the horizontal line test. And in this high school math class, that's good enough. After this high school math class, that's not good enough. Sometimes, yeah, certainly after calculus, that's not good enough. Maybe pre-calc, it's still probably efficient enough or good enough of a reason. And then we have to find f inverse. So I'm just going to go through all the steps. F of x is 96,000 plus 80x. So then that's y equals 96,000 plus 80x. Because I'm recording, I'm not calling on a lot of people, so I'll just go through it. This one should not be difficult. We interchange x and y, so x equals 96,000 plus 80y. And to get y alone, I'm going to subtract 96,000 and divide by 80. You guys give me a head nod. Can I do that all in one thing? Yes or no? Is that okay with you if I do it all at once? Okay, then I'm going to. So when I subtract 96,000, x minus 96,000, and then I divide by 80, it'll all be over 80, and that'll equal y. And then I can use, I teach a lot of geometry, so I say things like I can use the symmetric property of equality by flipping them the other way. And then y is x minus 96,000 divided by 80. So f inverse of x equals x minus 96,000 divided by 80. By the way, I didn't really say this at the beginning, so I'll put that up there in a minute. But for this original, the domain was all real numbers from negative infinity to infinity. The range was also all real numbers from negative infinity to infinity. And so when I get down to the inverse, then the domain and range are going to be from negative infinity to infinity, and there's no more restrictions on that as we go. So letter B, and maybe I'll copy that whole thing, and then I'll just and then I'll put it on part B. For part B, it's the same thing, but now it asks, and I'll just get rid of that part of it. Here's F inverse. It says, what do F inverse of x and x represent now? Now what does x stand for? Now what does x stand for? So think about, what did we say x and y were before? Whatever they were before, we just interchanged them. X is now the total costs. Total is manufacturing, right? Manufacturing cost. And then y, or f inverse of x, is the number of stereos. So we've interchanged x and y, so we've interchanged the meaning of x and y as well as we go through that. So just be careful of that as we go. Now, the next question is going to be about domain and range. but this time it's a different concept of domain and range. We know this is a linear function, right? And it's still a linear function. What's the slope? 1 over 80, right? What's the y-intercept? I don't know, negative 96,000 divided by 80, whatever that is. But it's still linear, and so the domain, the theoretical domain is from negative infinity to positive infinity. But now we want to talk about domain and range in terms of this situation. So can I put all real numbers? Does it make sense to put in all real numbers as we look at this? And so I want to go kind of, it's to C, but I want to go back to f of x. So f of x is on here. What restrictions, if any, should we put in the domain of f of x and then also f inverse? So f of x is this 96,000 plus 80x, and x is the number of stereos. So what kind of restriction based on this problem should I have for x? What does x stand for again now in the original? Number of stereos. So is it appropriate to use -6? No. You know, is it super appropriate to even use 0? You know, are you doing anything? Are you manufacturing anything if it's 0? No, so I would say non-negative, right? I want it to be non-negative. So any other restrictions? What does x stand for? Number of stereos. So would I use 6.4? No. So what kind of numbers am I using? Natural numbers. I'm maybe using natural numbers. So my domain, and I'm just, because it's natural numbers, I'm going to write that, you know, sometime, would it be appropriate to say like non-negative integers, you know, non-negative whole numbers, natural numbers, and so I'm going to say I'm going to restrict my domain to using natural numbers. Okay, that's the domain of f of x. Then f inverse of x, which is it 90, x minus 96,000 divided by 80? Somebody just give me a head nod. Okay, x minus 96,000 divided by 80. And now, 80. What does x stand for now? What does X stand for now? Our total manufacturing cost. So is that still going to be natural numbers? I don't think it is. So I think it's going to be what kind of numbers? Well, I want to relate it to this rule actually as I look at this. So when I put my my total cost in here, think about the y value is going to be my what is the y value going to be? It's going to be my, what does y stand for? Number of stereos. So my y is going to be my number of stereos. For this one, I think I have to say that my domain is going to be multiples of 80, because I have to get out these, right? So I have to go with multiples of 80. Why multiples of 80? Because I wanted to divide out, right? That are bigger than 96,000. Because if I put in 96,000, what am I going to get here? Put in 96,000. What's 96,000 minus 96,000? Divide is 0. So I think I have to have multiples of 80 greater than what? 96,000. Okay, and that's a little trickier for me to think about. And do you agree that really the domain and range of the rules, all real numbers, not a problem, right? And so in this case, we kind of have to find what is happening there. And then for the next one, we want to think about what's the better rule to use. And so there's still, this is kind of a terminal question. Letter D, A, B, C, D. Letter D is going to be if I have some value, my question will it be better to use f of x or f inverse of x? And then we'll have to kind of figure it out. You ready? So here's, and let me just write, oops, I'll rewrite up here f of x and f inverse of x. So f of x is always on the slide, 96,000 plus 80x, and f inverse of x is x minus 96,000 divided by 80. And so it says find the number of stereos made if the total cost is $216,000. So our total cost is $216,000, and we have to find the number of stereos. Which rule should we put it in? The inverse. So we're going to use the inverse, and if we use the inverse, 216,000, is it x or y? It's x, right? So we kind of have to kind of flip everything around. So we want to find f inverse of 216,000, and you'll have to tell me what that is. 216,000 minus 96,000 divided by 80. How many stereos did we make? $1,500? Yes. So 1,500 stereos. And tomorrow, just my announcements. The quiz on 1-7 is on Monday. The notes are due by Tuesday, but if you want to turn them in earlier than that, I'll look at them in class. The test will be Tuesday. Tomorrow, we will have a little bit of a couple problems to work on related to this lesson, and then you will have quite a bit of work time. And I did put up this homework 8A. It's 76 pages 76 to 80, 2 through 66 the even, and the key will be on my YOLO site after class on Monday, just to let you know. And so make sure that my straight edges get put away. My basket is right there. And oh, guess what though? You do have to stack the chairs because there's